All right, you guys, we're doing lesson 2.4 today. So let's go ahead and take a look real quick, all right? Okay, first thing is we're actually going to review a bunch of logs before we start. Okay, logarithms are like E, ln, um, E and ln, and then like log base 5, log base 10, stuff like that, right? You guys remember it. It's kind of like shows you over here, but here's how I like to say it. Okay, if log base b of a equals x, right? This is in logarithmic form. In order to change that into exponential form, we go b to the x equals a. And remember, we would always do that. All right. Um, in terms of ln in logarithmic form, ln of a equals x. Let's say, well, you guys, ln is base e. And so when I'm doing that, I go e to the x equals a. So I'm going to kind of write that in if I don't see it. All right. And that's the exponential form. And we can go back and we did quite a bit of this last year, so I think that hopefully you guys will remember. So let's look at a couple of examples real quick. Okay, 3 to the 4th is 81. We know that's a true statement. So as a log base, it would be log base 3, that's my base, of 81 equals 4. And then I just check it real quick at the end. 3 to the 4 is 81. Cool. Make sure I put it right. Now, if you don't see a base on there, this is actually going to be base 10. This is called the common log. So you don't see a base, it's base 10. When I change that, 10 to the negative 1 equals 0.1. All right, so it's just changing my forms back and forth. Okay, here are some log rules. Since e to the 0 is 1, okay, we know that anything to the 0 is 1. Well, let's rewrite this. E to the 0 is 1. So ln of 1 is 0. This is our first big log rule. We got to remember that all the time. Okay? ln of 1 is 0. That's an important one. Since e to the 1 is e, okay, what's ln of e? Well, ln of e is 1 because look, as it goes e to the 1 is e. Okay? So ln of e is 1. That's our second big ln that we have to memorize. Then another. So ln 1 is 0, ln of e is 1. And then here's these rules. It basically works like this. Okay, you're kind of cool. Because these are inverses of each other, right? ln of x and e to the x are inverses of each other. When I have like ln e to the n, those are inverses. That just becomes n. If I have e to the ln of n, those are inverses. That just becomes n. So those both just equal n. Okay? So use the inverse idea from 3c to simplify. ln of e to the root 2, so that's log base e of e, so that's just root 2. The ln of 3x, so that's just 3x. That's simple. Okay? Those are some good rules about e. Okay, here's some properties that we have. I think you guys will remember this. If I'm multiplying on the inside, it's the same as separating it out and adding. If I'm dividing on the inside, it's the same as separating them out and subtracting. And then there's this rule where the exponent could go down in front, or vice versa. The number in front could to be an exponent, okay? So that's like my third log rule. All right, so here's how we do this. So if I'm expanding logs, because I am dividing that, dividing means subtract, that's going to be ln of 5 minus ln of 8. Now, why do we need to know this? Okay, literally I told you we don't simplify anything ever unless it's in a multiple choice question. A lot of times, especially with e's and ln's, they will use log properties to simplify the answer. So it's like you don't only have to know the calculus, but you got to be able to simplify it. It's a little bit annoying. Okay, check this out. This is a cube root. So if I forget that, that's like to the 1/3 power. So I'm going to bring that in front. To 1/3 ln x squared plus 1. and then I can't do anything about it. Okay? Condensing goes like this. Let's see. All right, there we go. Anything in front, I'm going to put into an exponent. And then because it's adding, I'm going to multiply these. So just because it has a negative exponent, I'll probably write it like this. I'll put the x to the third on the bottom and the y to the fifth on top. Okay, so that's condensing logarithms. Like do another one here. So actually, okay, so that's going to come up. And then this time I'm actually going to leave the minus down there to show you something. Okay, look, plus means it's multiplied, minus means it's divided. Here's what I'm going to do. ln of x to the 1/2. Now you can write that as x to the 1/2, or you can write square root of x, okay? Times x plus 1 over y to the third, because that's divided. All right, so hopefully you guys remember, most of these log rules. Let's go over a couple more, I guess. We got a couple more log rules to go over. Okay. If I'm subtracting these, I divide what's on the inside, right? So I can put x over x minus 8, okay? Okay, then I can change this to the exponential form. All right, which tells me 2 to the third is x over x minus 8. 2 to the third is 8. And now, I can kind of just put that over 1, I guess, and cross multiply, or at least multiply that up there, multiply that up there. So I have 1x equals 8x minus 8. If I distribute, subtract the 8 over, so x is 64 over 7. Okay? Is everybody good so far, hopefully? Alright. Change of base formula. Now, to be honest, you guys, we actually don't use this as much because your graphing calculator will do any log base. The old ones couldn't. Let's take a look at the graphing calculator real quick here. Figure out what okay, so there's 2 buttons. One's right here on the left, log and ln. That's typically what we're going to use. All right, so if I go back out to the screen, what's log of 10 to the 5th? Right, well, I know that log base 10, this is a common log. Log base 10 and the 10 will cancel out. Just give me 5. Okay. What about if I just e to the ln of e and ln will cancel out. Just give me 2. There's those buttons. Now, your calculator will actually do other bases. It's under math, and if you scroll down, it says log base. Old calculators cannot do this. So, for example, on example 7, I'll come back up in a minute, but on example 7 where it says, use your calculator to find log base 7 of 112. I don't actually have to do a change of base formula, okay? 2.424. So I can just come right up here and go equals 2.424. Now the reason we have a change of base formula is for something like this, when the calculator didn't used to be able to do separate bases. We would go like this. Log 7 of 112. Okay, I take that, change it to base 10, and then I take that 7, change that to base 10. And I make 2 separate logarithms, log 112 over log 7, and then that's my new answer. So log 112 over log 7. And this should give the same thing. And I could change it to any base I want. So, for example, I could do ln of 112 divided by ln of 7. Okay? Alright, so that's how that part works. Let's see. Yeah, so basically, you can change this by taking log of whatever onto the top, and then log of that, and separating it and making it two separate logs. Okay, great. Alright, let's do these next two reviews, and then we'll talk about this. Alright. How do I solve this, you guys? So typically we want to get the bases the same. If it was like a 3 and a 9, we could get those the same as 3 and a 27. I can't really get 3 and 6 to be the same. But here's what I'm going to do. I can solve this by taking the log or the ln of both sides. Okay, now why do I do that? Well, then I can bring the x plus 2 down in front. Now if I want to solve for x, subtract ln, or sorry, divide ln 3 on both sides. Okay, and then I can just subtract 2 from both sides. So I end up getting x is ln 6 over ln 3 minus 2. The next part says use your calculator to find a decimal value. Okay, so if I go ln 6 divided by ln 3 minus 2. Okay, and that's what I get for my answer. Negative 0.369. Alright, let's move on to derivatives of sine and cosine. Alrighty, guys. Now, this is kind of cool. Let's check this out. This is the graph of sine, okay, from negative 2 pi to 2 pi. We're going to estimate these slopes. So I'm going to start with negative 2 pi. That's right here. You guys, who says a positive slope, right? And it looks like it's going up, like up 1 over 1. Let's just call that a positive, okay? Now I'll go to the next one, negative 3 pi over 2. What slope is that right there? There we go. Oh, didn't look like it, but there we go. That's a 0 slope, okay? Then we go to the next one, negative pi. Where does you keep going through here? What kind of slope does that have? A negative one. And then that has a 0 slope, and then that has a positive 1 slope. Okay, so let's keep going. That has a 0 slope, negative 1 slope, 0 slope, positive 1 slope. Okay, it says, plot those points in the coordinate plane and connect them to make a smooth continuous curve. Alright, so check it out. So the slope here was 1. I'm going to go up to 1. And then it was 0. And then it was negative 1, 0, 1. 0, negative 1, 0. Okay, here we go. Any ideas what this graph is? So that is actually the graph of cosine x. This is very cool, you guys, because now we have our first derivative statement with trig functions, and it's this. The derivative of sine is cosine. We can kind of see it from the slopes right here. All right? So, the derivative, here's how I would write that. The derivative of sine is cosine. Write that better. Okay? Now let's see if we can figure out the derivative of cosine. Let's just kind of look on my graph here, all right? Okay, I'm going to go ahead and put cosine of x right here. And then below it, I'm going to put the derivative, so that's math 8 of x of y1, or you can just type like cosine x, that's fine. If you don't want to go find the y1. And then we put x equals x, and it will draw it, okay? Now first, I'm actually going to turn this one off for a minute so you can just see. I'll do a zoom trig. That's the graph of cosine. All right. Now let's turn this on and let's look at what the derivative is. If you guys can guess what you think it'll be. All right, there's my derivative. Now, let's go ahead and turn off the cosine just so we can see this a lot better here. What graph is that? It goes through 0, 0. Looks like a sine graph, but here's the thing, you guys. Normal sine graph goes, I'll plot it for you right here. Normal sine graph goes up first. This goes down first. So how do I make this the same? It's actually negative sine graph. And now you can see that it's the same thing. Okay? All right, perfect. So now we just made our next derivative statement. All right, so this was cosine. And then this was the derivative of that. Something like that. And the derivative was negative sine. Okay? So check this out, guys. Very, very important. Put a big box around this or something, however you want to do it. Derivative of sine is cosine. The derivative of cosine is negative sine. We just have to remember that negative. Okay? Alright. Use your calculator, graph e to the x and its derivative. This is my favorite derivative, guys. Is that weird? Like, do people have favorite derivatives? I don't know. I do. Okay, so here's e to the x. And then here's the derivative of e to the x everywhere. Okay, now you gotta watch this a little bit carefully, okay? Check it out. E to the x, there's the derivative of e to the x. Did you guys see that? Okay, let me turn this one off for a second. Okay, here is e to the x. Here is the derivative of that. It's the exact same thing. This is actually really cool. Okay, so this was e to the x, kind of went like that. This was derivative of e to the x. What do you notice? Wow, it's the same. This is cool. E is the only time that the derivative of something is itself. It doesn't change. Okay? The derivative doesn't change. So, if you look right here, the derivative of e to the x is e to the x. Alright? The derivative of e to the x is e to the x. Okay, here's our last one here. The function ln of x is graphed at the right with some tangents shown. Alright, there we go. That's ln of x. Fill in the table by estimating some points. Okay, here we are. At 1/2. Okay, what is that tangent line doing? Let's see, it's going like... That's probably a slope of 2. Okay, at 1... So it's going up 1 over 1. That's a slope of 1. At 2... That looks like it's like a flatter slope. Maybe it's like a half. At 4... See? Looks like it's maybe even smaller than that, a fourth. Alright, at 6... Maybe it's a 6. Okay? See what's happening? You see how these are all like inverses basically? Here's how this works. the derivative of ln of x is 1 over x. Kind of see like the 1/2 goes for 2, the 2 goes for 1/2, etc., etc. Okay? So, the 4 that we just learned, you don't have to rewrite that, but look. Derivative of sine is cosine. Derivative of cosine, negative sine. Alright? The derivative of e to the x is itself, is e to the x. And then the derivative of ln of x is 1 over x. Those are 4 new derivative statements that we just learned. Okay? Alright, so let's look at a couple of examples. Differentiate correct notation without using a calculator. Alright, here we go. 2 can stay there. The derivative of e to the x is e to the x. The 3 can stay there. The derivative of ln of x is 1 over x. And let's remember how to do the derivative of a square root, you guys. Well, I need to put this to the 1/2 power. So when that comes down, it's 1/2 x to the negative 1/2. And I'm actually okay leaving my answer like this. That works for me. If I wanted to simplify it, I would maybe write it like this. 3 times 1 over x is just 3 over x. And then x to the negative 1/2 is x to the 1/2 on the bottom, which is a square root. Okay? Here we go. Pretty straightforward if you have these limit rules memorized. Alright, if g of theta is 3 sine theta minus 5 cosine theta, g prime is 3, derivative of sine is cosine. 5, derivative of cosine is negative sine. And so then that'll be my answer. I'll just do negative. Okay? Okay. Find the indicated value, you guys, to plug that in once I find the derivative. So here we go. The derivative is 15. That just stays there. Derivative of sine is cosine. Plus 4. That just stays there. Derivative of e to the x is e to the x. It's itself. So now if I'm finding h prime of 0, that's cosine of 0. And that's e to the 0. Okay? To get cosine 0, you guys, I got to remember my best friend chart. I'll do it over here real quick. This is the point 1, 0. Cosine is the x. Sine is the y. So, cosine of 0 is 1. And then e to the 0. You guys remember anything to the 0 is 1. Okay? So that value of that is 19. Now, I did that without using a calculator, but if I want to check it, you guys, we can actually check this. It's pretty cool. Okay, let's go over here. Let's go back to our home screen. Go math 8. Let's find the derivative of, okay, so it was 15 sine x plus 4 e to the x. Evaluated at 0. Whoops. I meant to put that over here. Okay, we got 18.999, which is basically just 19. Okay. Yeah, so let's take a look at this one. Ooh, careful, look, we're finding a second derivative. Okay, the first derivative, 4, stays there. Ln of t is 1 over t. Okay? 3 stays there. E to the t is itself t. Now, I got to take one more derivative, but you guys remember that when I go to take the derivative of this, I actually can't take the derivative when it's on the bottom. I've got to move it up. Okay? So let's rewrite this as 4t to the negative 1 minus 3e to the t. Now let's take a second derivative. Okay, remember this part is our power rule. That comes down in front. So that becomes negative 4 t to the negative 2 minus 3e to the t. Probably a better way of writing that is negative 4 over t squared. All right, and then my last step is evaluating it at 5. So it's negative 4 over 5 squared minus 3e to the 5. Which is fine. You can leave it like that, or you can write your answer as negative 4 over 25 minus 3 to the 5. Okay? All right, the last question we're going to do here is equation of the tangent line. You guys, as I go through here, the second I see those words, equation of the tangent line, I write y minus y1 equals mx minus x1. And I go, okay, here's my x1, that's pi over 4. The way I get my y1 is I just plug it in right here. Let's see what I get. It's negative 3 cosine pi over 4. And pi over 4 is root 2 over 2. Okay, so the y value is negative 3 root 2 over 2. Well, negative, positive. And now I just need to find m. Okay, so in order to find m, I'm going to take the derivative of this. Negative 3. The derivative, you guys, of cosine is negative sine. So negative 3 times negative sine, it's just, 3 sine x. At pi over 4, that's also root 2 over 2. Okay, so my slope becomes 3 root 2 over 2. Am I going to simplify this at all? Absolutely not. Okay? There we go. So let's talk real quick about what I want you guys to do for homework. This whole first part is just like review, no calculus stuff. Should be pretty easy, right? Writing it in logarithmic or exponential form. Simplifying, I mean, it's like literally that simple, right? Solving without a calculator. Do, like that. Properties of ln's, where if it's multiplied, it's added. If there's an exponent, you bring it down front. Okay, solving those, and then that on your calculator. Log base 3 of 20. Okay, next. This says differentiate. These are derivative questions. I want you guys to do all of these. Okay? These are all just derivative questions. These are also derivative questions, but they are derivative and then plug in a point. Okay, so for example, like right here, we're going to take the derivative and then plug in power 4. We're going to take the derivative and then plug in 0. If you want, you can check these on your calculator. Don't do them on your calculator, but you can check them. Okay, if you want. Equation of the tangent line, I want you to do that one. Tangent line parallel, I want you to do that one. Okay, let's go ahead and skip. I'm going to give you a couple to skip. You can skip those. Don't cross it out, though. We might go over it later. Skip that. You can skip that. I definitely want you to do 32. Average rate of change of slope, instantaneous derivative. Those 3 are good. You can skip 36. You can try 37. I'd like you to do 38 also. Okay? So let's do all of them except for the ones I circled. 28, 29, 30, 31, 36. So what did we say that was? 28, 29, 30, 31. Yep, 28, 29, 30, 31, 36. Okay, hopefully that lesson made sense to you guys, and I will see you tomorrow.